All right, so today in class, I've drawn a little view of the Palace door entries right up here. You can see the solar panels, and you can see Tyler standing on the roof here. This is Tyler, dropping his little green egg, and you can see Tabitha down here. So you can see I made the word problem. Tyler drops an egg on Tabitha from the Palace roof. He wants to yell her name, so she looks up as the egg hits. But he wants to know the time of free fall, so she cannot avoid the egg. And our discussion here, after we find the time, is if he yells her name right as he lets go, can she avoid it? Okay, so we'll talk about that. The first thing we got to do is figure out what we have here for problems. Well, okay, so we're going to figure out how long the egg falls. And we all agree before we turned on the recorder that it's about 25 feet from the edge of the Palace roof to the top of Tabby's head. Okay? So here we go. I would argue that you got to do the knowns first. Wow, the computer's really slow today. All right, the knowns here are that we have a vertical distance 25 feet. He's not throwing the egg, he's dropping it, so the initial velocity is 0. And the only thing making that egg go faster and faster is gravity. That is the acceleration. You mean 9.81, you mean?
Yeah.
Listen, 32.2 is feet per second, 9.81 is meters per second squared. So it depends if you're in SI or English. So you use 32.2 because you go with feet.
Well,
Thank you.
timing.
All right, now, here's Mr. Anderson's thing. The other thing I'm going to do is write the unknowns in the equation, but the red here, I want to be clear about this. Did you guys catch that I made the origin, the egg, and I called down positive? Only in physics would we get away with such a moment for math, but it works better this way. So down is positive this time. We'll call it a positive 25 feet. We'll call gravity positive. Both are acting down. The unknown is time, from when he releases it to when it goes flat. All right? And there are 3 equations to consider. You notice I wrote the 3, but I crossed 2 out. I think the equation we want to use is S equals VIT plus 1/2 AT squared. Because everybody agrees there's nothing happening in the horizontal. This is a y direction. We're not worried about components today. So if you fill in the blanks, VI is 0, so we get to do that. I get 25 feet equals 1/2 32.2 feet per second squared t squared. And again, I'm not going to waste time with the algebra. We can all solve this. I think we get t squared is 1.55. So it's 1.24 for the time itself. I have to take the square root. So, do you really want to yell Tabby's name as you let go of the egg?
No.
She's not that quick, so yes.
So there's the argument that she's really slow.
I'd say if it was about halfway down, because the reaction time for hearing it and then,
All right.
and then seeing it and then reacting.
It's like-
It doesn't move.
Listen, I would argue even Tabby can react faster than 1.24. All right?
I'm thinking
So-
25.
So you probably want to let go of it and think to yourself, instead of going 1/1000, because again, if you yell it, it takes a few tenths to look up even. So I think you would want to go drop 1, you're thinking 1/1000 for a second. You go 1, 1, and then you go Tabby.
I would drop it. Tabby and say it louder.
Tabby! And then it would hit. All right? So the real question here is, now, since, there's a problem here. You don't want to get in too much trouble. So the real question, the other thing is the egg going to be going too fast? So again, let's find the final velocity. How fast is too fast? We'll talk about that at the end. Let's find the final velocity first. Has everybody done that already?
Yeah.
All right, so I'll go fast. I think the best formula is this. And I'm going to change A to G. Because the initial velocity is 0, and now I know the time. So my final velocity is 32.2. Okay, it is. It's next Wednesday. Everybody, what do you get? Who did the math here? What do you get? 40.1 feet per second. Remember, 88 feet per second is 60 miles an hour. So the egg is cruising. The egg is cruising a little less than 30. It's definitely going over 25 miles an hour. So, the $1 million question. Think about it. Our dart gun the other day was 35. I think we're okay. It's an egg. The mass is not that good. You're not going to hard boil it, are you? Okay, because that would
It makes
change.
a mess the other way.
It makes a mess the other way.
Either way, it's
Not
still an
my
egg.
hair.
All right. So again, this is how we can do it. Now listen, this is free fall. This is free fall. Now, do you really think? Here's the challenge. Do you really think that Tabby is going to walk directly under the edge of the Palace rope?
You have to call her at the same time, so she stops to pick up her phone.
You just got.
Uh-huh.
It's relative motion. You use as she's walking down towards the doors. You just walk along the rope at the same exact speed. Relative motion. If you let go of the egg, that motion will carry. All right. All right. Nice little problem. Dropping an egg on a student's head. Welcome to Judah.